All right, so guys, this is one of those problems out of, well, this is probably 5.1. It says verify that the equation is an identity. Okay, so first thing I'm gonna do here, guys, there is an even in the notes for 5.1, you're gonna have all those identities there, Pythagorean identities, quotient identities, and there's one of them that says even and odd. Even and odd, okay, and that looks like a P, it's supposed to be a D for odd. Okay, and one of them says that the cosine of negative x is equal to just the cosine of x. So when I see this part right here, I'm not going to mess with this negative sign yet. I'm going to go ahead and leave that alone, but I'm going to say that cosine of negative x is the same thing as the cosine of x. And then we do have a plus secant, so let me go ahead and write plus secant x, okay? So let me go ahead and run like this, negative cosine of x plus 1 over 1 plus 1 over cosine x. And remember what I'm trying to get to. I'm trying to get to something that looks a little bit like this, right? Okay, so in order for me to get these two together, I need to get a common denominator. My common denominator is going to be cosine x. So I'm going to put cosine x here. And this one was already a cosine x. I already had a 1 here. So I had to multiply this by cosine x, and I had to multiply that by cosine x. So that's going to give me a negative cosine squared x, okay? And then what I'm going to do now is I'm going to rewrite this as cosine x, and then the top part, I'm going to write it as a negative cosine squared x plus 1. And then I'm going to just rewrite the top part. I'm going to write this as 1 minus cosine squared x over cosine x, okay? And let me see, I'm going to go over to the next slide. And one of the Pythagorean identities we have says that sine squared x plus cosine of squared x is equal to 1. So if I were to take this equation and I were to leave this guy on this side, but I were to move the cosine squared x to the other, that would tell me that sine squared x is equal to 1 minus cosine squared x, right? So the reason why I want to do that is if I use this Pythagorean identity and I come back and I look right here and I say, look, I got a 1 minus cosine squared x. And a 1 minus cosine squared x is the same thing as a sine squared x. So this is going to be sine squared x over cosine of x, right? Okay. And remember what sine squared x means. It means that there's two of them. So I'm going to think about this as a sine x and another sine x. Oops. Sine x, let me fix that, over a cosine x, right? And remember what it is we're trying to get to? We're trying to get to a tangent and a sine. So I know that sine divided by cosine is tangent x, and then here is my sine x, right? So guys, really what I'm doing in doing these types of problems is, number one, I use the even and odd for this first part to say, look, what happens if I have a negative on the inside? When it's a cosine, it's just going to disappear, okay? So that's how I was able to get to this part. And then we rewrote secant as 1 over cosine. That's using one of those quotient identities. All we did here is just did a little bit of algebra so we can get a common denominator. We went to this step here. We just kind of switched our terms. Then we used our Pythagorean identity up here to say, well, if I have a 1 minus cosine squared x, that's the same thing as a sine squared x. And then I broke up sine squared x into a sine x with another sine x. And then one more time, we use a quotient identity for sine divided by cosine to give us tangent. And that guy just came down here, okay? So if y'all got any questions, let me know. I'm happy to help.